see about binomial distribution. So this is used in statistics to find the probability between any two trails. So here by trails what I mean is, for example, by throwing a coin we can determine, by throwing a coin 10 times we can determine how many heads and how many tails are our outcome. So from these trails we are going to find the probability of which is preferred. So where this can be used, real world applications is medicine. It can be access the effectiveness of a drug. So in medical field, we are for determining the effectiveness of a medicine. They are used in medicine, and in businesses they are used to compare any two products to the users. So the users prefer which product. So that this can be used, and in sports or surveys or elections. And these things also can be used to determine an outcome. And so this is like predicting something with the already given outcomes. So let's see a sum to explain it clearly. So here the sum is, in a large consignment of electric bulbs, 10% of defective. A random sample of 20 is taken for inspection. Find the property of that, and these three subdivisions are given. So here in the consignment of electric bulb, 10% are defective. We don't know which electric bulbs are defective. They have given only the percentage. So to find the probability of the something is defective, we take for example we take the sample as 20 electric bulbs from the same consignment. So first they are gonna see about what if all of them are taken 20 is none of them are defective. So we are going to first find the probability. So that they have given, if what if the 20 samples we got this all are good. So that means there are none defective. So before we going to apply to the formula, we have to find three things: P, Q and N. These are all essential to fill in the formulas to find the probability. So P is nothing but the probability of getting the defective bulb. So which we can find by so nothing. Probability is already we know the formula. So the given percentage is given in the numerator, and one is numerator. So this is P. Then we have to find Q, which is nothing but the formula is 1 minus P. So 1 minus 1 by 10, which is 9 by 10. So next we have to find N. N is already given in the question. We can take from the question, which is our sample space, which is 20. So with these three things, we are going to apply to a simple binomial distribution formula, and we are going to find the probability. So first here what our probability is, what if there are none defective in the 20 samples, not in the consignment but in the 20 samples. So the probability of x is equal to 0. Here x, what is x means? X is the number of defective bulb in the sample. So what if x is equal to 0? Then we can apply the formula, which is so the formula for binomial distribution is P of x is equal to So this is the formula for binomial distribution. We are just gonna apply what we found already. So here 20, which is sample space, and here C of 0, which means which is the probability of the defective bulb, which we found here. So 0, and then we are going to apply the P and Q formula, and again N and X. So from this if we solve. So mostly there are zeros. So the only answer is 9 by 10 to the power of 20. So that answer we can use calculator in exam, which is answer is 0.1216. So first subdivision is completed. Next is second subdivision. they are asking is all at most 3 are defective. So from the 20 sample, what if there are at most 3 defective? Which means there can be 1 defective, or there can be none defective, or can be 2, or can be 3, but not more than 3. So here the probability is 3. So P of x is equal to 3. P of x is equal to x is lesser than or equal to 3. So here we are gonna add 4 probabilities. So what if there are none defectibles, what if there are 1 defectible, and what if there are 2 defectibles, and what if there are 3 defectibles. So we have to apply the same binomial distribution formula which we done here 4 times. So this is for 0. There are none, and 1, and 2, and 3. So using this, we have to use the calculator and find the answer. So here we already know the answer here. So the remaining 3 we have to do the calculations. We can use the calculator and do. So that's it for the second subdivision. And for the third subdivision, what if there are exactly 3 defective? This is really similar to first question. That the x is equal to 0. Here nothing but x is 3. Very simple differentiation. So here we only need to change x is equal to 3, and in the formula we have to put 3 in those places. And if we use calculator and find the calculations, we will get the answer as 0.1. So that's it. Thank you.